Hi, let's continue our work on premium. As you recall, last time we finished the continuous premium, we've seen many formulas, and I said we need to use logic to derive those formulas. So it's not really memorization as much as it's recognition of a pattern, and then you apply what you know. So now we will continue our discussion, but we will repeat the same thing, but instead of doing it for continuous, we'll do it for discrete premium, right? So everything now is discrete. And in discrete premium, the notation that we will use is P capital P for the premium, and we'll use X for the age, right? So let's try to understand what we mean here. Here the situation will use the same logic, right? Remember, we look for the loss loss at issue random variable. So an individual age X here, X plus 1, X plus 2, then it happens here X plus K and X plus K plus 1. And if death happens here, then we will take out the $1 unit of insurance. Where we take it? We take it at the end of the year. But death happens here. So we wait until the end of the year to claim the insurance, or the benefit will be paid at the end of the year. However, at the beginning of the year, each year you pay premium. Whatever the amount of the premium, it's a constant, you pay it at the beginning of the year. So the last premium paid will be here, right? Then death happens here, no, then zero premium here, right? So now if we create the L loss function, as always, the loss function at issue. So remember, we take the present value of benefits and we subtract from it the premium, which is the constant, the amount we pay, and the present multiplied by present value of the annuity. The series of like we take the present value of, let's say, of the premiums. Now, we usually set it this way. Then second step, because this is the present value. Now we need to take the actuarial present value. Then we take the expected value of L, set it equal to 0. If you do that, then this one will become AX. There is no bar here, right? Because it's discrete at the end of the year. You subtract from it P, the same P capital letter, the premium, now multiplied by the life annuity, the expected value of the present value of annuity. It becomes like the annuity here, it was A angle K plus 1. This one, it was VK plus 1, right? The expected value of VK plus 1 is AX, and this one will become A. Now here is X, because we evaluate at time of X, right? This is 0. Now it's set to equal 0. Now we need to solve it. Then the premium is equal to AX discrete over AX. What I want you to see, this is very important, right? This we need to know. Always the same case, similar to continuous. I want you to see what you have here, the P. The P, you notice if you compare it with the previous one, it was like this. What you see here, there is no bar, and there is no, also for the P, there is no bar, and there is no also no AX, right? If you compare it with this here. So for the discrete case, the no bar will tell us that it tells us that it's discrete premium, or premium paid at start of year excuse me, And no X bar here, it's you don't see it. And what you usually see, there is X here. Yeah. But there is no X bar. And the no X bar is to say also here, what we say is benefit is paid at end of year of death. This one here, when we have the AX, it tells us benefit is paid at the moment of death in this case. Here is paid at the end of the year. This is exactly what we visualize it here, right? So it's very important to know how to read these guys. It's very important. It's a question many times difficult. It's because we don't know how to read this one. Now, you know, there are many formulas, but the same logic. If you knew the continuous case, now it should be super easy for you. But before we go into the other formulas, let's say this is L. Right. And L here, we know that the expected value is 0. What is the variance of L? Now, expected value of L is 0. Variance of L doesn't have to be 0, of course. Now, let's look at variance of L. Right? You know, we derived from the continuous case, we derived the formula. So now we don't need to derive it again. It's the same logic. The way we derive it, the same logic. Now we'll go directly to the formula. But if you know how it's to check how we derived it, you go back to the continuous case and you see how we arrived to this conclusion. So we'll have 2AX, like this is the insurance benefit with the 2 delta or 2 delta, right? It's with 2 force of interest. Subtracted from it is AX. This is the expected value of the insurance raised to 2. This is the second moment. Here the first 2 here is second moment. The 2 here is raised to 2, right? And now we divide it by now, because it's discrete case, we use D. What is D? It's the discounting rate. And what's discounting rate is I over 1 plus I. D. Right? So D multiplied by A, and this for the same year X. Now everything here is raised to 2 as well. You can also write it, you know, different way to say variance of loss at issue random variable can be also written 1 plus P X, you know, the premium 5%, 6%, which is a constant, divided by D, this raised to 2, and then multiplied by, again, by AX 2 second moment minus first moment raised to 2. So these formulas, you need to memorize them. How we derive them, you go to the continuous case. We spend a lot of time on showing how we derive them, but those you need to memorize them. Very important for you to know them, because questions in exam, you don't need to derive it, especially these ones in exams. You can go quickly, right? So we did one case here, PX, right? Let's take, you know, other notations. If you remember what we did in the continuous case, now it will be straightforward, very easy. Let's look at, you know, let's go down here. So PX again, what we said, it's AX divided by AX. This is whole life insurance, right? A whole life insurance that pays $1 at the end of the year. So what is the level premium? And when we hear level premium, the same premium using the equivalence method, right? The equivalency principle. Now, you might see it also this way. Should know it very straightforward. If this is now, there is no bar over the P, capital P, so the premium is discrete, 1. Second thing, we don't have A bar, the A capital bar, right? So then the benefit is discrete. So basically this one, if you visualize this one, this is x plus n. Here, if death happens, it pays $1 at end of year. Oh, sorry, not up to n. So when death happens, it pays $1 end of year of death. And if somebody survive, it pays 0. Yeah. This is what gets out. What gets in is P at the beginning of the year, and here 0. Right. So at beginning of year, start of the year, you pay the premium, right? So this one, it's straightforward. If you would write it, then this situation here, it's term insurance for n. Then we take the term insurance, the discrete case over n period. We divide it by a, the annuity over n. It's easy. Now let's alter this one. What if you see P, X, N? We don't see 1 here. Do you see 1? There is no 1 on top of X. And this is the endowment insurance. So this one, the difference between this one and this one here, if you remove this one here, then there's no 0 here. If the individual survive, then we'll get $1. Right? If the individual survive for this one. If the individual survive, then you get $1 here. $1 if survive. If survive n years. Right? So $1 paid if death happens within n years, and $1 if the individual survive. This is this one. So it's straightforward, this one, right? We take AX n divided by a same denominator, because you need still to pay the insurance over the same period. This is the endowment insurance. This is the term insurance, premium for term insurance. This is premium for endowment insurance. The other one is the premium for a pure endowment insurance. This is P, the capital P is the premium for a life at age X, evaluated at age X, for $1 if you survive n period. So if you visualize this one now we put the one here now. If you put the one here, then everything here, then there is no payment here. Zero if death occurs in, yeah, it's confused. 0 if death occurs in n years. Within n years you'll get 0, but $1 if you survive, if the individual survive to the n years, right? The premium is the same. You need to pay it level premium. So this one is straightforward also. Is all you need to do is you take AXN divided by A double dot. I usually don't memorize them. I just need to know how to read them, how to read these guys. If I know how to read them, then easily I can. This can be written also. You might see it NEX AXN, right? So not much here. The only one we did last time in the continuous case. Now think about this situation here. You have X plus H, X plus, yeah, let's keep it this way for now. Now imagine the premium is paid. So at the beginning of the year you pay the same premium, but only for each year. Here you don't pay anything after that. But insurance, you take it one anytime at the end of year of death, right? So this one, the way we write it, if it's discrete and the red is discrete, then we write it, this one is H P X, right? H P X, the way we read it, because this X, well, there is no bar on P, then it's discrete case, and there is no A capital bar or anything, all we have is X. So this one will be, read it as AX divided by AX is paid only H period, right? Simple. You can play with it, right? You can play with it, right? Imagine if this one is paid only to N, and then after that 0. If only paid to N, right? So this should be N. If only the premium is paid for H period and the insurance can be collected if death occurs within N years, then this one we can write it the same thing, P X, but now the insurance is paid N. This one will be A, and there is 1 here, right? Because there is nothing 0 if the individual survives. This will be AX N 1 over A small letter X. Now this one is H. Right? It should be straightforward, not much of it's just, if you understand really the logic, you can derive any formula you wanted. Now you might also think of it this way. Now this one, the difference between this one and, where is that, where we draw it? Not. This one and this one, here there is an extra dollar if survive. If you survive to here, you get an extra dollar. This is the same logic here. It's AX N divided by AX, but not N, is H. Right. There is no one here. I mean, this can be written also X So many ways you can write it. You can also come with the pure endowment. Then this one will be pure endowment. So many ways you can formulate this equation. Many ways, like it can be anything written, you can just, as long as you understand the pattern. Let's see how we can read it again. The P, capital P, premium. Now no bar, it's discrete. H, premium paid only for H years. Now X, age at issue. When we issue the policy, it's age X. Now this should be N, of course, right? Now the one here over N, this one here is pure endowment. Paid if survive age X plus N, right? N is the period, right? So this is how we should be careful, and it's everything is discrete because it's we can see there is no bar anywhere, right? Let's take a few examples here. It's important to take a few examples here. And what I will do here for these examples, let's use the life table. Let's use the life table for taking some examples. Let's take the PDF here. I want to get some of, so we can take few examples here. Let's take this guy here. Hopefully this is the correct one. Yeah, this is the correct one. Now let's take few examples here. We're gonna use the life table, and as I mentioned, you guys, you should have them downloaded. Always, it's easier to use. I always print them, get them ready to work on them. So let's see how we can now use life tables. I usually attach them to the exam if I ask you. If you're writing the Society of Actuaries exams, usually these are given in the exam. So I'm using the same one as Society of Actuaries to find. So we're gonna find so many questions. Now let's find one. Let's do premium. It's written P capital letter subscript 70. We know that this is premium for life age 70. So we need A 70 divided by A 70, right? This is, we read it carefully, and this is what we have. So we go to the life table. So we are at 70 here. So we need to look for 70, we need to look for AX, right? Which is 4281. 42818, right? 70, and then we go here, right? Now we need to have the A2 dots. Now we need this one here, 12008. You see what I'm doing, right? It's clear. 120083. This one will give you the premium for this. You need to pay at the beginning of the year. You need to pay 3 cents for every $1 of insurance. Or 3.5 cents. So if you have $1 million life insurance, you multiply this one by $1 million, right? 1, 2, 3, 4, 5, 6. For the premium will be 35,000 for this insurance, right? If it pays 1 million. Let's take a few other examples. Let's take another one here. Harder one. Let's take P70, and this is for 5 years. So we don't have H, so the premium is paid for 5 years, as well as the insurance is covering only 5 years. So this one is A70 for 5 years divided by smaller a, discrete, for 70, again for 5 years. You don't have this in life table, right? If you go here, you don't see that. But you have 10 actually here, right? If it's the question 10, you can use 10, but we don't have 10. The question is 5. If it's 10, it's easy, right? But we don't have 10. You have this one now, 5. So how we can calculate it? We take it on the side. It's easy. E70 for 5 years. This is easy. It's A70 5 plus 5 E70, right? This is what you do. Now you take now this one, A71 for 5, A70. Yeah, let's keep it here. A70 minus 5E70 for A75. Now you have everything in the table here. Now if you go to the table, you need A70. We already found A70 here. 4281. 42818. Now 5E70, go back to the table here. And you make sure that can be confusing here, so make sure to get the right one. 73295. 73295. Oh. $73,295. Now A75, same logic. You go to 75 now, not 70. What happened here? Oh, just let me get it back. Now we go to 75. Go to 75. 50868. Oh, I have it written here, so 50868. Now if you then this one will, if you do the mathematics here, you're gonna get what I got here is 0.50534, right? So this one we got it. Five, 534. The 5E70 we already did it, right? We already did it. It's 0.73295. Yeah, well, sorry, the question here, I meant no one on top of it. Sorry, I meant no one on top of it. Sorry, I meant no one on top of this one. Right. I meant, well, yeah, I meant no one on top of this one. Sorry, no one. The question was no one. Right. Now we use the calculator for this guy here. Right. So now this one, because sorry, the P here, it has no one here. Correct it if now this one we take what you got here, we write it here, 0.78829 divided. Now we need to 875. There are two ways. Now we need to take A75. Two ways. I mean, you can do things faster, but here, because I need to explain them to you. One way is to say 1 minus A75 divided by D, and D is I over I, or the alternative way, A75. I mean, let's do this one and then we do the alternative way. It's 1 minus what we calculated here. This is 7889. To 9 divided by D, and for life table you would see that's 5% for this life table. You would get here to be 4.4459. This is one way. But just if you're curious, the alternative way, directly from the life table, 70 minus 5E70 and A75. You can also do this one. So we have the A70 and then we take the 75 from it. Let's see if we get the same answer. So now we need the annuity for 70. And the annuity for 70 is 12.0083. 12.0083 minus 5E75. I think we did it many times here. 73295. Now A75, this is A75. You go back here and you look for A75. It should be this 103178. And if you calculate them, it must give you the same answer. Must give you this exactly the same answer, 4459. If little bit of difference, that is because of rounding error. So this one is the same. So this one should be equal to the alternative way we did. Let's have equal sign, right? Both of them, they are equal. Now we got everything to calculate what we wanted to calculate, right? This one will be four divide 459. If you calculate this one, equal right. So this one, and remember there is no one here, right? But let's do, because I as I mentioned, I made an error there. I wrote one, but let's do that one. What if we don't have an let's do this one here, calculate it on the side. Let's say 3 P75, and there is one here. This will be A71 5 divided by A75. So now the A75, we already calculated it, the A70 with 1, which is this one here. Right? and the same denominator. Same denominator here. The only thing, the numerator is different. And if you do this one here, you will get 0, 1, 2, 4, 4, 8. So this is the P75. Now imagine if you are asked question number 4 to calculate P70. This one. This can be written 5 E70 divided by the same one, E70. This one can be, we already calculated it here, this one, 3295 divided by the same denominator. Alternatively, P75 is equal P75 plus P75. Let's verify this relationship. This one I got to be, so this one we got it to be 0.164859. 70, this one 0.1248. Then this one should give us 0.1733. Let's do 4. Let's verify if we got the same answer here. Right, here it is. 77307. Little bit of differences, it's because of the rounding. Right, so you see different ways to calculate the very same things. Now it might get, you know, little bit, another question. What was this question for? Let's do 5. You might get one like this now, question 5. You are asked 3P, let's say 70. We use the same logic. It's A70 for 3 years divided by A73. We go to the life table here. You try to see if you have the 3. You don't have anything with the 3 here, right? If you try to find the 3, you don't have. So let's see how we can do it if you don't have the 3. So let's take the A70 3, and the A74. Oh, sorry, this is not A3, A70. Let's keep it A70. A70, we have it. It's fine. We already found it many times. It's 42818. This is fine. Now we need to do the A73. The easiest way is to say A70 minus 3E70 multiplied by A73. Right. A70, it's easy to get it. 12.0083 minus now 3E, sorry for that. Now 3E70 you don't have it, you have 5 or 10. And then the A73 here is 11. 110081. But where we get the 3E70, this is easy, right? Because we did it in previous sessions. 3E70 is L70, 73. The cohort surviving to the year 73 divided by L70. Now we go to the L. What is L? The cohort that survive to the age of 70. You look at your table here. This is the L of X. We look at the cohort surviving to 73 and we subtract from it this, we divide it by 70. So now if you like, so we need this one and this one. Sorry, multiplied by V3. V is the interest. So L73, I'm gonna use I showed you where to find it. L73, it's 87916.8 divided by the 70, 90, 91, 082.4 multiply by V3. I is 5%, so 1.5 raised to minus 3. This one will get you to the number of 0.842588. So this is the 3E70. If you multiply them all together, then you plug it in here. Now you get this creation here, the number we got here. You plug it back here and you do the multiplications. Then the answer for A73 is you will get 2.7. This is what I got. Now you get back this one. And now we have the A70 already, we found it. Then 3P70 will be, after you divide them, you will get 0.156. There is not much of difficult complication or difficult questions here, except you need to be careful how you compute things, right? If you just follow the logic from the life table, you can quickly calculate many things. The last thing before we finish the life table, since we are in quickly, I think it took us a long time here, but it's, imagine now we're gonna take this equation. Now they have a question here that we need to find in L is the loss at issue random variable. The expected value of L is 0, but we need the variance of L for life age 65. Question like this, we quickly write it. Variance of L equal, you have many formulas. I'll use this formula 2AX 65 minus A65, everything is discrete, it's saying to us, and its whole life, there is no term, right? Raise it to 2, divided by D, and divided by A65 as well. Everything here is raised to 2. Now, where we find these guys, 2A65, we go back to our friend the life table. Now 2A65, this one, you get up to, sorry, you go up to 65, 1542, you see it's given here. And this one, as I showed you, 1542, subtraction of A65, A65, you go to now this A, 65 is here, 3547, 35477, but this one is raised to 2, divided by, what is D? Is I, and I for the life table is given to you here, 5 over 1.05, this is D, multiply by A65, A65 is 135498, everything is raised to 2. And now if you do the calculation for this one, if you do the calculation for this one here, variance of, where this disappeared, sorry, it disappeared, so the variance of L, if you do this one, sorry, this is, I don't know where it disappeared, but 425, and this one is A5 is 13, the variance of L, if you do the calculation here, it will be 0, 0, 1, 1, 7, 9, 8. Right. So I think we're done with this one. It's a bit of a long session, but we've done a lot here. So again, you need to practice the life table. Especially now you have assignments, so you solve so many problems with the assignment. Many questions like this to get used to finding values from life table. All right.